So hey guys, welcome back to another video. Today we'll discuss about what is database sharding. So let me just write database sharding. Okay. So what is database sharding? First, let's take an example of pizza slice. So let's suppose that here we have our pizza, and let's have some slices of it. So let's suppose that we start with 0. Of course, we are coders. So 3, 4, 5, 6, and 7. So let's suppose that you have a pizza and you have divided these slices to your friends, right? So that because you can't eat this pizza alone, so you have divided this to your friends, and this is known as partitioning, right? So you have partitioned the pizza and distributed it to your friends, so you can finish it. This is known as partitioning. So let's suppose that these slices are the servers. Okay, so let's suppose that this is just add s. So this is s0, s1, s2, s3, s4, s5, 6, and 7. Okay, so these are the servers and the requests that are coming. Let's suppose that these are the devices and these are the servers s1, s2 till s7. So these requests are coming from devices, and we are distributing this according uh, to the user ID. So let's suppose that we are distributing this request according to UUID, which is the user ID. So we have a mapping of 0 to 100. So the user IDs that are between 0 to 100 get distributed to this server, S0, 100 to 200 this, 200 to 300 this, and same goes on. Okay, so we have distributed this request, but this is not the right approach of distributing the request, because if let's suppose that there are multiple requests of 0 to 100, this won't get balanced across all the servers. So that is the issue, but let's discuss more. So okay, so here what we are doing, we are using key. User ID is a key, right? So user ID as key. So we are using user ID as a key, and we are distributing the request. Now comes so the thing that we just did is a horizontal partitioning. So let me just write that. Okay. So basically, what is horizontal partitioning? So whenever you distribute the request to the servers according by using some kind of row or some kind of key of the data that you have, is known as horizontal partitioning. So basically, whenever you use user ID or any property of the user for distributing the load to the servers, that is known as horizontal partitioning. Now, opposite of this is vertical partitioning. Vertical partitioning basically means when we are trying to access data based, when we try to distribute request based on the columns instead of rows. So column means whenever you are dividing data based on columns, this is known as vertical partitioning. Okay, so this is useful when you have tables with many columns and not all columns are frequently accessed together. That time vertical partitioning is very useful. Horizontal partitioning uh, is based on rules, of course, and this is useful when you are trying to access particular data. Okay, now when we talk about server, these are the database server, these are not normal servers. So let me just add that. Mhm. So these are the database servers. So these are the database servers. So each database server has some kind of data, and we are running our query in that database so that a single database doesn't get too much load. So these are the database servers. Now, points to keep note of is while sharding, we need to make sure that there is consistency in the data. So what happens? Let me just write that first. So there should be consistency in read and write. Read and write operations means let's suppose that we have read write operation on S5 server, S5 DB server. It should be replicated uh, to another servers if there are any replicas of this server, and the data that we have wrote should be equivalent to the data that we are trying to read. So read and write operations should be consistent. So read and write should be consistent. Now comes the second point, availability. So there should be no crash. Actually, let's suppose that there is a electricity is out. So what will you do? So at that time also your database or your record should be available. For this you can of course use master slave architecture. I will explain it after some time. So like there is one example, like a Tinder application uses location for sharding the database. So location wise servers are divided and load is balanced. So it makes read and search operations very faster. So what they do, what Tinder do is based, let's say that you are in Mumbai or you are in some location in Rajasthan. So what will happen that Maharashtra's location would be stored in S6 server, database server. The data for Maharashtra location would be in S6, and for Rajasthan it would be S7. For Gujarat it would be S0, and same goes on. So these are based on location. They divide the database. So that is also a type of sharding. Okay. Now, so the problems in sharding. So the first problem is of course joins. So let's suppose that if we have a cross shard, then query needs to pull out data from both shards and join the data across the network, which is a very expensive call, of course, which is a very expensive operation. So what I'm talking about, let's suppose that this is our chart and there is a cross query that we have, and the data that we require should be from both servers. So on the network call, the query has to make the joins and return the data, which is a very expensive call, right? So that is a problem with charting. Okay. So second problem is this is not flexible. Like you can't have more servers. It's already defined, right? So there are seven servers, 7 or 8 servers, which are already defined. You cannot have more servers. For this, what we can do, we can have consistent hashing. So that I will explain in some other video. But using that, we can have any number of server based on the number of requests we have, and we can divide these servers into more minor servers, I would say. So first problem is of course consistency. Second, not consistency. Right? So first problem is joins. Okay. Second problem is it's not flexible, which are fixed number of shards. But this can be solved using consistent hashing. Or let's suppose that you have some. Let's suppose this seven pizza slice, and what we can do, we can have some kind of manager here. Okay, and this manager, what we can do, this pizza slice or this server, this database server, we can further divide into smaller chunks, and this manager will make sure to distribute that request according to the id or whatever you are using for horizontal partition. So according to that it will divide. This is sort of a consistent hashing, but in a smaller level. So it's not flexible, of course. So now after problems, now comes what are best practices. So just write that. Best practices. So first is of course have an index of some key. So like in database, having indexing is of course better for search or delete or whatever operation that includes search. Because indexing is always better because it helps you to query the database quickly, right? Now let's suppose in the database there, let's suppose this Tinder application example that we were using, the location based sharding. So what we can do, we can have a indexing. Let's suppose we have a indexing of each according to each. So what we'll do, we'll, let's suppose if there is a query that like find all the members, all the people in Mumbai which are more than 20 years old. So that will be a quick thing, right? Because it will be easy because indexes are based on each. Okay, so have indexing. First is indexing based on any key. Second is of course, let's suppose let's suppose that there is a electricity out. If electricity is out or it's cut, okay. So what you can do? Your database or your data would be gone, right? So what you can do to avoid this? You can have master slave architecture. What does it mean? So master slave architecture is basically, let's suppose that the we have master database. Let me just have that database thing. So let's suppose that this is the master database. These are its slaves. Okay. So this is the master DB. This is slave 1, slave 2, slave 3, or whatever number of slaves you want, you can make it. So what happens? This master have the uh, most updated copy, most updated data, right? And what slaves do? Slaves keeps on replicating the database and make sure that the replica of master is always present in the slave. What happens that whatever request that comes, so whatever write operations are there, that goes to master. Whatever read operations are there, that goes to slave, and slaves returns all the data that can be read on the device. Okay. Now what happens when the electricity gets cut? What happens is your master goes down, of course. So what slave does? Slaves try to decide, pick one master among themselves and make that as a master, and others are already slaves. So let's suppose that S1. So let's suppose S1 become master, and these three become slave. Okay. So S1 become master. All write operations now will go to S1, and read operations would go to the slaves, remaining slaves. Of course, the data would always be replicated. So using this, it becomes a SPOF, which is single point of failure gets avoided, or it's SPOF tolerant system. Okay. So SPOF is avoided. Please ignore my handwriting. Actually, this is the new app that I'm using, so it's getting some issues. So yeah, that was about sharding. This is what sharding is. So yeah, thanks.